Okay. Hey, what's up? It's Chief here, and this is a departure from my normal programming tutorials. I'm a avid Destiny player, and today a new piece of the alternate reality game that Bungie's been teasing dropped, and instantly I noticed that it was a what looks like a 8,000-bit AES certificate or key. So what I'm going to do is run it against some OpenSSH X509 tools to see if there is some issuer and subject details in there, or determine if there's a specific fingerprint with this particular message. And I suspect that several different players have seen different fingerprints. So I suspect that there's different keys out there, and this certificate could be either the private or the public key. So let's check it out. I'm going to share my screen here. There is a Hangouts link for this, so if anyone wants to drop in and talk, more than welcome to. Let me grab the link here. Okay. All right, so what I want to show you first is what happens when I just create. I gotta stop this. When I just create a key, and this is important because I think from what I've seen that there is a fingerprint that is out there. So let me create a key real quick. Okay, so you'll notice here that I got this symbol. So I just created this key and I got this symbol. What that is a fingerprint. It's a random art image to help identify the key, and you can use that to verify the key hasn't been altered in any way. Now, if I go to okay. So there's two pieces that were generated by that one key. So now what I just did is generate something using RSA encryption. It's a different encryption than the key that we saw on the website. There's a hint that it's AES, but I want you to take a look at this. So if I cut out this public key here, you'll notice that it looks like this. And then if I check out the public version, so like I said, every key has two pieces to it. There's a public and a private. And the public key you put somewhere, like another server or something, and then it identifies who you are as you connect to that server, and it looks different, and it looks like this. Now, what we're looking at is most likely a certificate, like a certificate of authority. And those are most commonly found if you go to a website and you see it says HTTPS. They are signed using a certificate. So let me share. A different program here. Okay, so for example, this is the OWL sector website. And so I'm clicking on the certificate details here, and it's telling me that your connection to the site is private, and that's because that key is exchanged, and it encrypts the traffic that happens between me and the client. It's not transmitted in the plane, it's encrypted as it's transmitted. In order to decrypt that traffic, I would need a private key. Another way to certify, if I were connecting another way, would be to provide a client certificate. And I think that is what we're looking at. So if we view the certificate here, we can see that it's this is an RSA. So you can see that things are encrypted with AES. It's a type of symmetrical encryption that says that there's an authenticated handshake and that you need a client certificate in order to complete that private connection. So what I'm going to do is, there was a link here. So remember when I created that SSH key, we had this symbol, that random art image. Now compare this to this private key that I had just generated. And obviously you can see that they're similar in that they have the equal sign at the end. So it tells me that we may be able to get some information out of here. Where would we go? So let me take this, copy this. Share my terminal here again. see. I created this sim.pem file, and I'm going to run -text no out in sim.pem. Here, someone else just logged in here.
Hey.
Who is it? How's it going?
Hey, it's Creature from the Discord.
Yeah. Okay, so there's no sightline. Expecting a trusted certificate. What cipher would we use? So I need to add that cipher to my list here. What was the name of that cipher? Okay, so this is AES 128 CBC. Enter encryption password. Are these processing key? Let's see. Plus EDL 5LA. Okay. EDL 5LA. Are you still online, man? The other guy that's in here? Can you hear me? Or either of you guys, Alexander, Zane, speak up.
I can hear you, man. You got me?
Okay, you said there were 7 other nodes. Are there 7 other keys?
I'm absolutely
Well, these would be certs, but
yeah, lost for words here, man. I don't know what's going on. I'm just lurking, enjoying the view.
what am I sharing right now? Okay, my terminal. Start line, so it's not a private key. Where was that site? Excited, you might be onto something there. I'm reading your message right now. So if you're using that AES online domain tool site, I can verify by looking at the code block here that our mode should be CBC. the weird thing is, I need that link again to the site. So I lost mine. There we go. So there's definitely a message in here. And if there's 7 other nodes, we need to put the 7 messages together. So AES CBC, so if it's, I don't even know how to pronounce it. If it's RISNet, that's got to be 256 encryption. Okay, so I got a salt out of that. Let's see. What's our salt here? Whoop, damn it. decrypt this. Let's see, AES 256 CBC. Initialization vector. Copy this key, man. Come on. So if there's still a missing piece. Do I not have that cipher? AES 256 CBC. What did I do? Ah. Okay, so we need to convert those symbols into hexadecimal. Okay, so all I need is to figure out okay. So the first one in my node is E299A6. Let's see, diamond, triangle. This is a downward facing triangle. Let's see, what's my node? Circle. Actually, I should probably be sharing what I'm doing here. Okay, and 2 downward triangles. Okay, layman's version. This is a message, and this message can be decrypted. And in order to decrypt a message, you need a set of common values. And so what we've got, what Bungie's calling the initialization vector, is most likely what is called the salt. And the salt is basically, there's 2 ways to encrypt stuff. You can salt them and you can hash them. And a salt is basically a way of taking a unique like character sequence and then running it through some sort of algorithm like MD5 or SHA-1 or SHA-256, or in this case, the Regendel encryption protocol, which is AES 256 CBC. So if we run that message, we use, this is a open SSL technology, and it's, I believe it's base 64. So if we try to decrypt this, input file, key file, key IVN hex is the next argument. Okay, so let me get rid of this. And I will paste my, oops, Control C. Let's redo this. I'm going to paste my hex code in here. So where does it say it's an image? Here are the shapes. I'll put those into the chat. Those shapes translate to hex codes. So if you can see what I'm doing here, let me reshare my terminal here. Okay, Taco. Captain, what was your crap? What was his triangle, diamond, circle, triangle, circle was E2. So let's see. What I don't know is were the triangles up or down? What am I sharing? Again, I'm on my terminal. Like, I keep switching to something. I'm just going to share my whole damn screen. You guys will have to deal with the size of it. Okay. Looking for black diamond suit. $26.66. 2666. It's not in here. 02666. Somebody said theirs was E2. Okay, I need to add the are those random art images capable of being copied? Probably not. Processing keys, the password. The initialization vector is the salt. Okay, so I need the salts, the processing keys, and the initialization vector for each one of these. 1, 2, 3, 4, 5. TDCDS. What does that mean? Okay, so let's see. Circle. And then diamond. in. Get the hex code for that. Oh, okay. Thanks. Diamond, square, triangle, diamond, square. 1, 2, 3, 4. 1, 2, 3, 4, 5. Diamond, square. So let's do. Hey, you guys can drop into this thing and chat with me. This is a live hangout, so. Okay. Just making sure. Node, let's see, you said diamond, square, triangle. Diamond, square, triangle, diamond, square. I need to re-verify all these codes to make sure they don't have spaces in them. Like this one I can tell right now is the wrong length, so that's got to be wrong. Go grab it. There's a space there. There's a space there. It's still wrong. There's still a space somewhere. There we go. Anyone else seeing a pattern? These are all the same hexadecimal output. So Furzion, you're riding the chief train, huh? Let's see here. I need to know what this node is. My guess is that'll tell us. So look, we got to find the matching nodes. That'll help us. So there's 8 nodes. Each node says that there's 7 other nodes, and that means that there is a key pair for each one. So we need to find the matches for each one. That's it. That's totally it. So look here. We know that node diamond, triangle, circle, diamond, diamond are matches. There isn't a chain. Only 4 key pairs. How's it going?
Going good.
What's your name?
Creature, dude.
Creature. Are you in the ARG forum?
I'm on the Discord, yeah. I was here before.
Yeah, Discord. Okay. Okay, so I'm finding that different nodes are matching up with the hex codes. So
I'm at work, man. I think I'm going to back out and see what's happening in a couple of hours. Good luck with it. Have fun.
All right, I'm gonna stop my broadcast here. Let the thread catch up and see what's going on.